Right, so today we're going to get into wind energy. So this is just a video, okay, to green energy, and visit this link. I'm not going to run the whole thing right here for you, okay. Make sure you copy and paste this link into your browser and watch this for your pros and cons, alright, of the wind energy. And it's only like about 4 minutes, right, for you to learn. So first of all, the advantages, okay, of wind is totally free, and we can use the modern technology to capture it efficiently. Okay, after you build it, you don't have to deal with the greenhouse gases, okay, or other pollutants, because wind turbines, they don't produce them. Yeah, and as you know, the wind turbine, okay, it takes up only a small plot of land, okay, because we build up into the air. Okay. So you have your kinetic energy, this is moving energy, change in the turbine into mechanical energy, and then we choose electricity, okay, by running the generator in here. Yeah. As many people find the wind farm, okay, interesting feature on the landscape because it's very exciting, yeah, to see them. And we can produce power in off-grid, okay, remote areas where you can get electricity. Also used in developing and developing countries, third world countries, because cost very efficient. All right, these wind turbines are, and also they come in sizes. Yeah, so you can get them. Depends on your budget. Okay, you can get a smaller turbine. You can get commercial turbine. Okay, depends on the amount of electricity that you want to produce. You know, for residential, you can get a smaller ones, about $300 to $400, I think, and it's good enough to light up your house. Yeah. So cons, the disadvantages. First of all, you can control the strength of the wind. You know, sometimes there's no wind. Sometimes you got a storm or hurricane. Also, people, right, they feel the countryside, okay, should be left untouched, because sometimes the wind turbines can mess up with the birds, flying south or flying north, okay. One is they are noisy, okay. Some people are skeptical about it because they feel like, right, maybe they are frightened, right, to see these wind turbines, in farm, right? So they don't like the look of it, probably, yeah. They don't feel pleasant even to look at it. So these are just a controversy, okay? This one, this one. Manufacturing these wind turbines comes with a pollution. Wind turbines themselves, they don't produce greenhouse gases, but manufacturing of them, all right, produce pollution. And you gotta go large in order for you to be able to provide enough energy to the entire communities. Okay, we've got to come up with so many wind turbines, right? Meaning like very large scale operating wind farms. So anyway, these are the disadvantages of using wind energy. Okay, so let's take a look at the basic, alright, design for your wind turbine. It's a horizontal axis, we call it HA, yeah. This is just a wind turbine. WT, VA is your vertical axis. So when you take a look at the horizontal axis wind turbines, okay, you can see some parts of it. Vertical looks like this. We're very familiar to this type, right? Commonly seen outside. So we have a rotor diameter from here all the way to the end, right, from the top to the end. We have hub height is from the center, right, to one end of the blade. Then you have your rotor coast. This part harvest, right, the incoming, what we call it inlet wind currents. Then here is your gearbox attached to your generator, okay, to generate electricity. This is just the stem or tower, and this is your base, okay. And here is just a cover, right? Vertical axis, the same thing. We've got the tower. The generator is now on the base with the gearbox, and you can see your rotor in a very different shape and design than this, and the diameter go from here to here. Yeah. Horizontal axis design from the top all the way to the end of the other blade. See the differences, yeah? And the hub height, the same thing, from center all the way to the end. The rotor height, top to the bottom, yeah? From the diagrams, we're gonna get into the definitions of your HAs, okay? HAs are your horizontal axis wind turbines. So if you recall, axis of rotation, yeah? Completely round, yeah? So this is your horizontal axis wind turbine. Your axis of rotation is right here, and that axis of rotation, so I can draw that out for you here, so you can see that, yeah, is completely parallel to the ground, okay. Here we have slope, here are some bushes, your ground is down there, yeah. Got it faced, all right, to the direction of the wind. So that's the only way to harvest the wind energy, and turbine is gonna convert, yeah. Winds again, kinetic energy, because the wind is moving. Kinetic energy is the motion energy. And then we're going to change it into mechanical, which is this movement, okay? So we call it ME, which is your mechanical energy, because this turbine blade's got to roll, okay? As soon as the wind hits, right, bam, these three blades. And turn that, right, mechanical energy to run the generator to produce electrical energy, okay? So don't forget KE. So kinetic energy, text will usually jump steps, yeah? But in your head, you gotta know that we are creating wind energy into force, which is your mechanical energy. And this energy is used, okay, in the turbine to run the generator, okay? And you're gonna get your electricity, okay? That's your electric energy. Okay. Direction is definitely not constant. Okay, so therefore when you put the turbines on your wind farm, you have to be careful of the direction of the wind in that area. Okay, so you can face these blades to that direction. So technology-wise, fans, alright, wind turbine, they can turn, right, automatically sense and turn their position to the wind direction. Yeah? So it means that they've got a yaw adjustment. We use this yaw, okay, in the yacht or boat, right? Sailing boats. So same as that. So we're catching the direction of the wind. So you have a yaw adjustment mechanism and automated, of course, using the sensor, sensor for motion. and then it's going to position these wind turbines right head to face against the wind direction. Yeah. So this advanced technology definitely enable these turbines or wind turbines to maximize the energy conversion efficiency. Okay, because they're not localized and they can be able to turn their head right head to the direction of the wind, so the efficiency goes up. Just like showing you, right, still in horizontal axis wind turbine, just showing you the design information. Not going to reiterate this anymore, right? You got it already in your first diagram. Then here I wrote in meters, 1981, and then we're now in 2000. See the size, yeah? It's going up. Ratings get better, yeah? Annual, okay, megawatts per hour. That is the production, alright, capability of these wind turbines going up. You can see the trend, yeah? Right, the next type is your VA, vertical axis wind turbines. See, you don't outside, okay? They're not commonly seen in the environment. So anyway, VAWT, so those are your vertical axis wind turbines. Pretty new. So they have rotor blades, okay? And they spin, yeah, instead of the other HA design. So here you can see the design is completely different. And it's been parallel to the ground, yeah? So here is your ground. So the same thing in parallel, medium parallel, yeah, I'm not very good in drawing. So they can operate anywhere and you don't have to worry about the wind direction, okay? Instead of our horizontal, okay, axis like this. Since we're doing the spinning, right, mechanism, it doesn't matter where the wind comes, yeah, this way or that way, or this way, yeah, it will definitely rotate the blades and you can get the mechanical energy and then your electric energy. Here is difficult, yeah, because you've got to face and you have to also have advanced technology to turn with sensors, automated one to turn if the wind blow from the opposite direction, yeah. So anyway, new designs again, BA, you update all the mistakes that we made, yeah. When we built it, we wasn't thinking about it. Yeah, the direction of the wind can be anywhere, even though it is common to us. We know the wind, right, since long time ago, yeah. But then, when you build it, you didn't think about from which direction the wind can come, yes, and you didn't think about this kind of design. See, so anyway, continuous improvement is that, yeah. Do something, we made a mistake, we find our mistakes, we use our mistakes, and then modify the design. Okay, so mistakes are good for growth and opportunity to do better things. Yeah. So VA, we're gonna stick it right into the places where your wind goes crazy. Yeah. Meanwhile, you can control the direction of the wind in one way or the other because they come in like where from 360-degree around. Okay, so the gearbox, right, and the generator box got to be right down here, stick to the ground, yeah, because you can put it up right here because you need to capture the wind from different directions. So we gotta get this box out of the way. Here, the box is up there, yeah. Okay, so therefore the length of the tower, right, doesn't need to be so high, like in your horizontal axis turbine, yeah. Okay, well, that's for your vertical axis wind turbines. Some pictures, so you can be able to see variations in these vertical axis wind turbine. We have this, we have different, look at this, like Merriweather here, and then this way too, and this designs, yeah. So make sure you Google it, and you can come up with many different better pictures than this. Okay, then we're going to take a look at the differences between the vertical axis and the horizontal axis wind turbines. So you have already understood vertical axis wind turbine came, they turn parallel, right, to the ground. This should be 90 degree. I'm not good at drawing. Because of that reason, right, the blades of the vertical axis can turn against the wind, so you can lose the efficiency. Yeah, efficiency means energy conversion efficiency, because the energy conversion efficiency increases when these blades, okay, are in the direction of the wind. Yeah? So when you take a look at it, sometimes, right, the wind is going to come from this side, okay, and the blades can be against that. Yeah, so you will lose efficiency because you need time. Okay, by using that wind energy, still gotta turn the blade into the wind direction. And the tower height is lower, okay, than the horizontal axis wind turbine. So the vertical axis wind turbine, right, they can operate when the wind comes in a higher altitude, okay? So usually wind speed, okay, is faster in higher altitudes. So therefore, alright, VAs can produce less power compared to the HA design. Okay, HA, they have a very higher, okay, tower. So this design can reach the wind, the higher altitudes. Okay, stronger wind, faster wind. So you can produce the electricity better. And VAs, so you know their tower, right, is shorter, so their rotor blades like this, okay, it's definitely closer to the ground. Yeah, so therefore installation is pretty easy compared to your horizontal axis wind turbine. Okay, it needs to go all the way up. So here you gotta put more time in installation. This one is pretty straightforward. Of course, you get more power this way than the VAs. So now we'll get into maintenance. The same reason, the VAs are shorter, therefore it's easier to maintain. HAs are higher, right? Therefore you need technology to get up there to maintain. Yeah. Traditional HA, you gotta check constantly, yeah, to make sure that it is facing, all right, towards the wind and not against the wind. But of course, if your HA, all right, has a yaw adjustment mechanism and automated, then you don't have to worry about it, yeah. Because HAs without this automated yaw adjustment mechanism, you definitely need to constantly maintain, right, to get the best wind direction. Land area requirement. So when you think about the HA, right, they require a higher tower, right, and that is erected just straight up into the air. Okay. So it can reach to the higher altitude winds. Higher altitude winds are, as you know, they are faster, okay, so therefore they have more energy. And for vertical, alright, axis wind turbines or VAs, you need the cable, right, to stabilize the machine. The windmill, the traditional one, right, the HAs, they don't take a lot of space, so the base is just right there, and so they take up just like a very small plot of land right there. The same thing, right? VA doesn't take a lot of land either. But the issue, okay, with the VA, the spinners, is they need the cables, alright? And that cable can take up more land, yeah? So VAs are like, they can spin and, like, they can be able to catch the wind in different directions, but still they produce less power, okay? And also comes with the cable complications. Okay, so here we're looking at some data, and you can see there is a trend right there. Yeah, see that? So we take a look at the data in 2005, and then we go into 2015, right? So that's 10 years. Yeah. So in 2015, you take a look at the value right here, and you got 63. Okay, gigawatts. So giga is 10 to the power 9. Okay, so that's a lot, right? And we started out right here from 12, right? 12 gigawatt into we can produce up to 63 gigawatts. So that's the wind power generation. Of course, this is the worldwide data. So if you calculate and do the math, right, that's about like 22% increase from 2014, because 2014 we have only 52, okay, gigawatt. So here we can take circle it so you can see. If you want to know what these colors are about, you can look at the legend, and alright, this darker point is just showing you the annual addition, something you add, right, at the end of the year. This is your original capability, your capacity, yeah. So from world total into countries. So let's break them down. You have China, you have US, Germany, India, Spain, UK, Canada, France, Italy, and then Brazil. Yeah. Where you know the size of these countries. Size meaning like they have more open land, alright, to accommodate the wind turbines. So if you look at, let's look at Italy right there. Italy, okay? They don't have a lot of wind energy or wind turbines, alright? Wind energy harvesting wind turbines. They don't have them because, why? Because of their country, they don't have open spaces, okay? We have open spaces. China, they have open spaces, okay? UK, no, they don't have open spaces to accommodate the wind turbines. Yeah, you got it. Because they are more sophisticated cities, so therefore populated, right, with people and also buildings. So the same thing, you have addition and then capacity, original capacity. China is going so high because they're adding more, 30. We're adding about 8. Germany adding about 5 to 6. India can't do it because the wind over there in Asia is not as strong as the wind in China or in the United States, okay? Because of the terrain is different. India is just hot, right? Hot and humid in the south. And this is kind of like 2015 data, yeah? Okay, so let's go to the next slide. Okay, so let's see the trends in this business. And for this textbook is 2016 data. So wind turbine, right, is pretty good because it is becoming the fastest growing job. We have many different states, and these states definitely strengthen their RPS, which is your renewable portfolio standards, meaning like they have interest, right, in wind energy. Fortune 500 companies, your Google, your Microsoft, your GM. But actually, we also have industries like Mohawk, okay, and Cox Industries. I don't know why this textbook is not mentioning that. So anyway, these are tech companies. They're pushing, right, to become 100% renewable power because they're motivated to do that to save their tax, right? Because you get a lot of tax credit. Polls, right? Data from the polls from public Americans, all right? They favor the wind power group. Of course, some certain groups, they have some arguments and controversies and all that against the wind turbines, right? But that's just minor, Majority of the Americans definitely favor the wind power. G. Okay, for US capacity, you have already seen the previous slide data, So we're adding more, right? So our US capacity in 2016, we can power about 20 millions, all right, homes. Offshore wind power, okay, it's definitely the American power, like next generation power. So from 1 all the way to 6, right? Your top 6 wind power trends. Make sure you read them. There's a new innovations, all right, in design, of course. So they want to use right here all the traffic structures, right? They're just trying to design it that way so that you won't be taking ground space and integrating into the existing structure that way. Many different other types, right, of designs you can see, right? This is offshore, and you can see here too a very different, This looks like the side of the air conditioning, right, unit, just the bigger ones, and we're definitely expecting, all these new designs outside, right, giant, so we gotta build, because in the future, in near future, we have to do something to control, right, that wind currents in your ocean, okay? Let's draw with a different color. So anyway, ocean, right, wind and the ocean currents are very important because they carry tremendous energy when they move, because there is a great mass in them. So when large masses like that moving, right, we can definitely harvest that energy, Even we can harvest that energy to divert the hurricane or tornadoes or just our, tropical storms. You can break them down, or weaken them before they hit the people and the homes and the businesses. Okay, so here are more relevant video links for you to go and watch. And all you have to just right click it and then copy that link and then paste it in your browser, right? I'm not going to run the whole thing right here for you one by one, so just take time, and this is on your own to watch them. Alright, so I'm going to go ahead and end right here.